some research background. And the motion of coin falling into the bottom of the tank that is filled with liquid can be remarkable, similar to the fluttering and tumbling of the falling open lid. And investigate how the motion of the coin depends on relevant parameters and equipment. And we have prepared several coins such as $1, $5, $10, and $50. And also the stakes that its width, length, and height is 12 and 15 centimeters respectively. And the experiment design to measure how coins fall under different conditions. The variables we have prepared is the size of the coin and the angles which it was dropped at, and also the distance between the coins and the water surface. And during this experiment, we held the coins by hand and also observed its tumbling of the motion. And we will record the process by phone. We compare the horizontal and vertical flow of the coin. This is $1 coin and in 180 degrees, and this is $1 coin in 90 degrees. Is vertical. Other is $50 in horizontal degree, and other is $1 in vertical degree. And this is our core question. Does the weight of a coin and its enter angle affect the coin oscillation and number of leaps when enter water?
Next, let's look at our principle of the experiment. When a coin falls in water, we use the fluid resistance formula. So when we horizontally put the coin into the water, the area A touching the water is the largest, so the F, the resistance, also the largest. We can look at the photo 1. It's a perfectly horizontal drop. So the right side and the left side feel the same resistance. So the coin will falls into water slowly and straight down because it is stable. In a slightly tilted horizontal drop like a photo 2, the right side feel more resistance, so it will fall into water slowly, and it will adjust itself to the horizontal direction, so it will move to right or left, but the speed v is small, so the F resistance also be small. And next, photo 3, the perfect vertically drop. The right side and the left side feel the same force, so it will be very fast power into water. The picture 4, slightly tilted vertical drop. Push the coin to left side because vertical falling has less resistance. The coin moves very fast near the bottom. The fast water flow pushes the coin move more strongly. To one side, so the coin quickly moves down and to the side. This picture can show the one perfect horizontally drop into water, and the coin falls horizontally leave from its path and far from the center also can improve that formula. Number 3 picture of our experiment. And this is number 4. The coin falls vertically and leave it from its path and landed far from the center. And the red shows it's very vertical.
This is our experimental data, and the experiment results show the coin type is $1 coin, $5, $10, and $50, and this is its diameter and mass, drag angle, and position in water. This is energy oscillation count and energy rotation count, and the coin with the smaller mass with the high oscillation, and the coin with the larger mass with the fewer oscillation and rotation.
Based on the experimental data, placing the coin horizontally affects the number of oscillations, and placing the coin vertically affects the number of rotations. When placed horizontally, oscillation differences among different ways are small, but show more rotations when placed vertically. When placed vertically, oscillations decrease as weight increases. Overall, lighter coins show more rotations and oscillations. One problem in this experiment was uneven force when placing the coin by hand. To adjust this, the same person placed the coin each time and try to control the force, rising and using only reasonable data for analysis. During the experiment, we found that this week's results were very different from last week's. When the results did not match our expectations, we checked the experimental procedure, made adjustments, and considered possible reasons for the differences. That's all for our report. Thanks.
I think that group can memorize your lines and also can provide us the data. And do you have any questions for the group? Who wants to get extra points? You can ask the questions. I want to ask a question. Please go back to the experimental data. Don't you think your spelling is wrong? Experimental data. DETA. What is that? Okay, so you have to revise it, right? And about the table, because the figure is so small, can you explain the main point of the data?
Point is 这个重量比较轻的那个，它就是它的那个摇摆次数跟那个翻转次数会加上，然后重量比较重的它会比较多。我们测出来是。
Okay, maybe you can use other color to circle it, or give us a sentence to show your result. It's better to make your listeners understand. Okay?
Okay.
So very comprehensive. Do you have any other questions? No? you right? Okay. Now please give them a very big clap. Good job.